grade. Today we're going to be talking about what our next science standard is, which we're going to be breaking up into 3 parts. It's heating and cooling and how they affect materials. So that's 5P3.2, and this is our actual standard right here, which is explain, can you see that good? Explain how heating and cooling affect some materials and how this relates to their purpose and practical applications. So we're actually going to be building upon our knowledge that we learned last time, which was on heat transfer through the forms of conduction, convection, and radiation. We talked about how conduction is that transfer of heat energy through direct contact, and convection is those currents of hot or cold in a fluid, which means gases or liquids, and then radiation, which was the transfer of heat energy through electromagnetic wavelengths, like through the sun's rays or in microwaves. So those were those particles that travel through space and transfer heat energy. So we're going to be building upon that information, and we're going to be breaking it into what does it exactly mean if something is heated. If you're heating something, you're actually increasing those molecules' heat energy. The faster those molecules move, the higher the temperature. What is cooling? Cooling is when there's actually a loss of heat energy, when there's a decrease in the amount of movement of those molecules, and as they slow down, they're losing heat energy. When you think about that, when we talked about moving from a solid to a liquid to a gas, they had varying amounts of energy. And the same thing is true when we're talking about heat energy. So we're going to be looking at how we heat things up, how we cool things down, and which different materials in our everyday lives are going to be conductors, which actually allow heat energy to move freely through them, and then insulators, which are materials that do not allow heat energy to easily move through them. And we're going to be talking about different things. So I'm going to go over a couple things that are in your everyday life that are insulators and conductors that you might not have thought about. So this is my winter hat. So my winter hat is a wonderful insulator, and it's a wonderful insulator because it's made of really, really thick padded material, and it has layers that trap air inside, and air is an excellent insulator. It helps to prevent the transfer of heat energy. So when I wear this in the winter time, it's going to keep all my heat energy inside my body and prevent my heat energy from traveling from my body and going into the cold air around me. Because heat likes to travel, as we learned in our last standard, from hot to cold. Another wonderful insulator, my wool sweater. It's so comfy. It's an excellent insulator. It traps, again, lots of air in between those fibers, just like it would on the sheep. And air is a wonderful insulator, and this is a nice, thick, comfy, soft material, which helps to keep my heat energy in. Another one, wool socks. These are itchy, but they do a good job of insulating your feet so that the heat energy doesn't leave your feet and go into the floor. Now, we don't really think about it when we walk on surfaces like tile or linoleum and we're barefoot. We think that it's because the floor is cold, but actually when you're feeling that cold sensation, it's because the heat energy is leaving your body and traveling into the cooler floor. And as that heat energy leaves your body, it gives you the sensation of feeling cold. So an insulator like wool socks will actually prevent that heat loss from your body and going into the floor. And you can prove that that's what's happening if you just feel the floor. Have somebody sit on the floor and have them get up if you have tile, like maybe in your bathroom, and then feel the floor. You'll feel it's warm because their heat energy left their body and went into the floor. And the same is true on metal chairs. If you sit on the metal chairs in a classroom and somebody gets up and you sit in their chair, you'll notice it feels warm. That's because they've conducted their heat energy from their body into the chair. That doesn't happen on some surfaces though. If you sit in a cloth chair, for instance, you're not going to have that same kind of thermal energy transfer that you would if it was a metal, because metals are conductors and cloth tends to be an insulator. Rubber spatula. Rubber is a wonderful insulator. If I was to stir hot batter with this, it wouldn't burn my fingers because I'm not going to feel the heat transfer like I would if I was stirring with a metal spoon. Metal spoons are conductors. Anything pretty much that's a metal is going to be a conductor. If I was to stick this in a pot of hot soup, it would travel the heat energy up to the stick that I was holding, and the handle would get very hot and could burn me potentially. Cork! Aha! You've probably seen cork. This is the top of one of my medicine, herbal medicine bottles. And cork is a wonderful insulator. It does not allow heat energy to pass through it. Ceramic. This actually happens to be a very cheaply made ceramic bowl, and when I put something in this and I heat it up in the microwave, it's very hot. That's because ceramic can be a conductor, and I've burnt myself many times on this bowl forgetting that it's not microwave safe. So you got to be careful about things like that. Metal roasting pan for my turkey. Again, conductors typically are metals, and so this is excellent for heating up a turkey in the oven. So different properties, different materials will have different properties that make them good and serve different purposes. Like for instance, when you are dealing with insulation in walls, there's foam insulation a lot of times, or that pink fluffy looking cotton candy looking stuff that goes in between our walls that helps insulate our houses and our rooftops so that we can maintain a year-round temperature, so that the hot from the outside doesn't come inside in the summer, and that the hot on the inside doesn't go outside in the winter. So you're going to learn a whole bunch of things. Don't forget to fill out your matrix and your questions and do your sort. And if you have any questions, feel free to give me an email, a dojo, a call, or however it is that you want to communicate with me. I hope you're all doing well. I miss you, I miss you, I miss you, I miss you. Enjoy your lesson. See you later. Bye-bye.